section 421 today, and 421 is titled Sine and Cosine Ratios. We're going to be looking at pages 11 through 13. If you have your own calculator, great. If not, when we break up into groups, you're going to pull out your Desmos scientific calculator. And then if you have a highlighter, go ahead and get your highlighter ready. We are going to be answering the question, what if I know the hypotenuse? Okay, so for question 57, it says to find out how high Juanisha climbed. In problem 56, you need to know more about the relationship between the ratios of the sides of a right triangle and the slope angle. Part A says use two different strategies to determine the change in y for the slope triangle shown in the diagram at right. Okay, so we're going to use something called the Pythagorean Theorem. The Pythagorean Theorem is a squared plus b squared equals c squared. And so from this triangle at right, we know that one of the legs is 3 squared. The other leg we don't know, so that's where we're going to plug in our x. And the hypotenuse, which is opposite the right angle, is 6. So we're going to plug that in for c squared. Then we're going to square each of those. 3 squared is 9, and 6 squared is 36. Is 9, 6 squared is 16. Then we're going to subtract that 9 from the 36, which gets us 27. And then we need to take the square root of both sides. So if you have your calculator and you take the square root of 27, you're going to get, oh, that gave me the decimal answer. Let me switch it to this calculator to a decimal. Oh, there it is. Switch it to a decimal. No, it's not switching it to a decimal. No. Okay. As a decimal, it's 1.73. All right. Question B says, calculate the ratio of the change in x to the hypotenuse for each triangle. Why must the ratios be equal? Okay, so for these two triangles, they want us to compare the change in x to the change or to the hypotenuse. So for the smaller triangle, it was 1 to 2, and for the larger triangle, it was 3 to 6. So I set up the proportion, 1/2 to 3/6, and then I did the cross product. So 1 times 6 this direction, set it equal to 2 times 3 that direction, multiplied them out, and I got 6 equals 6, which is what you would expect. So these are going to be similar triangles. Okay. For question part C, it says, determine BC and AC in the triangle below. So the first one they wanted was BC, so I put an X there. And the second one they wanted was AC, so I put a Y there. Okay? So I'm going to use the similar ratio from this triangle right here, which was 1 to 2. Then I'm going to set it equal to x to 7. So I have that similarity ratio, make it into a proportion, and then to solve your proportion, you do the cross product. So you're going to do 2 times x, which is 2x, 1 times 7, which is 7. Then to get the x by itself, you divide both sides by 2, and 7 divided by 2 is 3.5. So that gets you this leg down here. Then we need to get AC, which is the side that I labeled with the y. Since I now know 2 of the sides of the triangle, I can use the Pythagorean Theorem, which again is a squared plus b squared equals c squared. So this leg we just figured out was 3.5, so I plugged it in for A. The hypotenuse they gave us was 7, so I plugged it in for C. The side we want to solve for is the y. So 3.5 squared is 12.25, and 7 squared is 49. So we subtract the 12.25 from both sides, which gives us 36.65. When we take the square root, we get approximately equal to 6.06. Make sure you use the wavy equal sign because I got a decimal, a continuous decimal. Okay? Any questions on problem 57? Okay. All right. Now we're going to start learning a new trig ratio. So if you have a highlighter, go ahead and highlight the word sine ratio. Okay? In problem 57, you used a ratio that included the hypotenuse of triangle ABC. There are several ratios that you might have used. One of these ratios is known as the sine ratio, pronounced sine. This is the ratio of the length of the side opposite and the acute angle to the length of the hypotenuse. Okay? So in this triangle at right, from this 60 degree, we would use the sine ratio, would be the side opposite over the ratio of the hypotenuse. Okay? So for the triangle shown at right, the sine of 60 is going to be equal to the square root of 3 over 2, and you're going to punch that into your calculator and get approximately 0.866. Okay? Another ratio comparing the length of the side adjacent, which means next to, the angle to the length of the hypotenuse is called the cosine ratio, pronounced cosine. For the triangle above, the cosine of 60 is 1/2, which is exactly 0.5. That is written, the cosine of 60 degrees is equal to 1/2. Okay, so let's see how we use this in all practicality. Top of page 12. Problem A says, like the tangent ratio, your calculator can give you both the sine and cosine ratios of your angle, of any angle. Locate the sine and cosine buttons on your calculator and use them to determine the sine and cosine of 60. Does your calculator give you the correct ratios? So if we type in the cosine of 60, we're going to get 1/2, which as a decimal is 0.5. Okay? So the answer is yes, the calculator gives us the correct ratio. If you don't have your own personal calculator, you're going to write down that you need to use the Desmos scientific calculator. And we'll be using those in just a minute. Okay? Part B. Use a trig ratio to write an equation and solve for A in the diagram below. Does this require the sine ratio or the cosine ratio? Okay? So we're going to take our highlighter and we're going to highlight the angle that's given. Not the 90-degree one, but the other one that says 23 degrees. Okay? From that 23 degrees, there's a side over here with an A. That A is opposite. So write down A is opposite. Okay? And from that angle, the side labeled with 15 is the hypotenuse. So write down 15 is hypotenuse. When we need the two sides that use opposite and hypotenuse, we use the sine ratio, which is opposite over hypotenuse. And then we're going to set up our equation. We're going to say that the sine of 23 degrees, I just got that measure from right there, is equal to the opposite side, which has an A, over the hypotenuse, which has a 15. And then I make a proportion out of it. If you need to put a 1 in the denominator, put a 1 in the denominator. Then you solve by doing the cross product. 1 times A is just A. 15 times the sine of 23. You simply type in the calculator 15 times the sine of 23 is equal, and then it's going to give you this big, long decimal. Okay, we're going to round it to the hundredths, which means two numbers after the decimal point. The number next to it tells you whether to stay or round up. You get a 0, you stay, right? So we're just going to say 5.86, but then you need to make sure you write your equal sign wavy, because that tells the person that you rounded, okay? That's a sign, okay? Now let's look at the another problem for problem C. It says, likewise, write an equation and solve for B for the triangle below. So again, you're going to take your highlighter and you're going to highlight the angle 37 degrees. From the 37 degrees, we have side B, which is adjacent or right next to, and we have the side 8, which is the hypotenuse. Okay? The trig ratio, or the trig function that uses adjacent and hypotenuse is the cosine. Cosine is adjacent to hypotenuse. Now we're going to plug in our numbers. So we're going to say the cosine of 37 degrees, just the measure that's right there, equals the adjacent, which there's a b, that's what we want to solve for, over the hypotenuse, which has an 8, so we write the 8 there. Once you have that proportion set up, then you can do the cross product. So we're going to have 1 times b, which is b, and then 8 times the cosine of 37. And then you simply type that in your calculator. So we're going to have 8 times the cosine of what? 37. And again, we get this big, long decimal. Okay? We're going to round to 2 places. So after the decimal, we have a 38, but next to the 8 is a 9. With a 9, we round up. So instead of writing 0.38, we write 6.39. And make sure you put that wavy equal sign so that you know you rounded. Okay? All right. Question number 59 says, Juanisha wants to know how many feet she climbed vertically when she walked up Filbert Street. Use one of your trig ratios to determine how high she climbed. Okay? So we're going to highlight the angle that they gave us. So you take your highlighter and you highlight the 31.5 degrees. Okay? From there, we have the change in y, which is opposite. And we have 100 feet, which is the hypotenuse. So we're going to use sine, which is opposite over hypotenuse. So to make our equation, we say the sine of 31.5 is equal to the change in y over 100. And then we do the cross product. So for the cross product, we're going to multiply, bless you, we're going to multiply 1 times the change in y, which is just the change in y, set that equal to 100 times the sine of 31.5. So to type that in the calculator, whoop, get it down in view, type in 100 times the sine, 31.5, hit the equal sign. Oh, did I write down the wrong answer? 31.5. Did I do something wrong? No? I wrote down the wrong answer. This should be not that. 52.2. There's a 4 there, but next to it's a 9, so we have to round up to 5. Huh. Okay. Question number 60 says, for each triangle below, you're going to decide which side is opposite and which is adjacent. to the given acute angle. Then determine which of the three trig functions